have started the topic about different techniques of agglomeration, right? And in many cases, agglomeration is very important. We cannot avoid agglomeration because we cannot charge fine particles into the reactors to produce metal. In many cases, one of the best example is during production of iron, right? When we want to produce iron, we never charge fine particles into it. We always charge lumps. So agglomeration process means basically we are converting our fine concentrate to lump concentrate, that's all. By using heat or by using different techniques basically. And I told you there are many different techniques of agglomeration. As if you remember, one is sintering, one is pelletization, one is extrusion, vacuum extrusion, others are briquetting and nodulizing, right? Apart from all these, the two important agglomeration techniques are sintering and pelletization. Sintering we have already discussed, right? And definitely when you go for your internship, you will see that machine, white load sintering machine, how they are doing sintering there. But this, in case of this, you have to remember, basically sintering is done for blast furnace iron making, right? When you want to produce iron by using blast furnace, there we are using mostly sinters. But there is a problem with sinter. What is the main problem? Just main problem in the sense that there will be lot of issues, but let me tell you some issues. One issue will be, in case of sintering, the entire fine particles will become a single lump. Right? Remember, a single piece of lump will be there out of fine particles. So again you need to crush it and you need to screen it to get the desired size, and the desired size will be fed into the blast furnace. So you are not getting individual big size lump. You are getting a big size lump and you are crushing it, and again you are doing screening so that the acceptable big size will be sent for blast furnace iron making, and fine size will be again recycled into the sintering process. So that is one of the issue. But if you look into this process, pelletization, in this process the fine particles, the mixture of fine particles will be individually become small spherical balls, individual balls. It will be not become a single piece of lump. It will become a one like this kind of thing. This kind of thing, individual. This kind of things, hard means they will become strong. So this is interesting, right? Because individual, we don't need any kind of crushing and all. We can avoid the crushing, right? And during the process, we can run the process in such a way that we'll get our required size of pellet directly. Suppose blast furnace needs 16 mm size. Basically, feed size will be 16 to 20 mm. Most of the blast furnace they run in this range. The size of the pellet will be 16 mm to 20 mm, 21 mm in this range. But if you remember, in case of sintering, I told that is 10 to 30 or 10 to 40 max mm, right? And another advantage in terms of shape, just see the shape of the pellets are spherical, nearly spherical, or egg or spherical shape. But in case of sinter, that was a big lump, you crush it, but during crushing you will not get spherical balls or spherical shaped sinters. It may be uneven surface, right? So now you tell me, so which one is good actually, technically? Spherical balls is actually good. Why it is good? Just imagine the blast furnace. If you are feeding pellets, in another blast furnace you are feeding sinter of irregular size. So if you need permeability, you remember I told you what is forming? Molten metal and molten slag are forming, which is moving down, and your hot gases are moving up, right? So you need permeability inside the reactor. Actually the blast furnace, if you look the height of the blast furnace, it is 40 meter. Just imagine 40 meter height, blast furnace height, right? So lot of ton of material is inside the blast furnace, and you want the carbon monoxide should move up, and you want a slag and metal should go down. It is a counter current process, right? So you need to move the gases, from bottom to top. What you need? You need permeability, pores, voids you need, right? And similarly, for moving down of this molten metal and molten slag, you also need this permeability, means voids through which it will go down. It should not stay up, it should go down and it will move to the earth. at the end. So if you fit pellet and if you fit sinter, which one is better then for getting good permeability? Pellets obviously because it is uniform size, very good uniform size. So you will get uniform size of permeability. Maybe the required permeability will be also more. We see, this is very important. We cannot run a blast furnace or a counter current reactor without having permeability, because some mass need to be go down, some mass need to be go up, right? You need permeability. You cannot run a blast furnace without permeability. So okay, I will not go into details in that. You understand? So pellet are good. They are uniform size, they are spherical, and they don't need any kind of crushing in between after preparation. So you can see this is, suppose for example, less than suppose 5 mm. Basically, technically if you see it is in micron scale. Thus I am considering this less than 5 mm, or maybe it is some in micron level. After mineral process. After classification and all. You may get it in micron levels, you can convert it into this size. This size is how much I told? This will be 20 nearly. This is acceptable size. So what are the requirements to do pelletizing? You need, so I am talking about iron ore, so you need fine iron ore which are very fine. You need a binder which will bind the particles. It's like a gum. And another important, this is very important, critical amount of water you also need, or you can write critical amount of moisture. These are the three things you need to make what I told, green pellets or green balls. Why they are green balls or green pellet? Can you just imagine? Because they are weak. They may break down. If you directly use them, they will break down. And they also contain moisture. Right. So that's why they are called green balls. Green balls means the strength is less, they may break down, and they contain moisture in it. Right. You cannot use any moist material into the furnace basically. Dry material you need to use always. Otherwise it will consume your heat energy. Because water needs to be vaporized, right? So it will consume some energy because endothermic process. Right? So that's why they are green balls. And hard ball means they will become very strong. And you have to also remember, whatever iron ore concentrate you are feeding into the furnace, they should be very strong. They should not break down inside the furnace. They can withstand the load, because you are charging ton and ton of material. You just imagine, ton and ton. So there will be heavy load, right? The bottom portion will be under heavy load, right? So they may break down. Just tell me, if they will break down, what will happen to the permeability? It will increase or reduce? It will reduce, of course. This point you always have to remember. In the blast furnace iron making, you have to always maintain permeability. To maintain permeability, the solids should be in a shape. They should not become powder inside the furnace. Right? So that means whatever raw materials you are feeding, they should be very strong. They should have very high strength. They should not break down. If they become fines, so the permeability will go down. So if you remember, I told you that why we are doing agglomeration. So this is one of the answer. That means in other way I can say why we cannot charge directly fines into the furnace. If you charge directly fines, permeability will be minimum. But if you charge lumps, voids will be there definitely. Of course, voids will be there. You can imagine a situation. Suppose you take a pot, earthen pot, you put lot of sand, very fine sand, for example, very fine, and you pour water. Otherwise you take a screen. On that screen you put lot of sand which are of very fine particles, very fine. Or you can take soils and put it and pour some water. The water will not permeate into the bottom directly. It will take some time, right? But if you take gravels, stones, small size stones, and put it on the screen and pour water, so water will go down easily, because these rocks will be having lot of voids. Permeability is good, right? So that is one of the reasons why we always need agglomerates, not fines, in the blast furnace iron making, because we need permeability. To get permeability, you need agglomerates, not fines. Just imagine And the point, just imagine, if you remember, in blast furnace iron making, we are purging hot blast from the bottom, right? From the bottom we are purging hot blast, and that velocity is also very high, 200 to 300 meter per second, just imagine. So what will happen if you feed fine particles? What will happen? It is a counter current reactor. You are feeding fines. उड़ जाएगा, very good. It will fly away from the top. It will fly away from the top. So that is called heavy dust loss. You will lose lot of materials because from the bottom the hot blast is moving up now, and you are feeding fine particles from the top. So fine particles will be carried away by the moving blast, right? So you cannot charge fine particles. You have to charge lump so that it will overcome the resistance of this flow of your hot blast. You understand the point? And similarly, just imagine in the blast furnace the temperature is very high. Starting from 200 degrees centigrade to, it will go to 2000 degrees centigrade. Layer by layer. 200, then 400, then 600. It will increase. So temperature is so high inside the furnace, and you are feeding fine particles. So what will happen? They will become agglomerate inside the furnace itself. They will become a single layer, maybe piece of single layer. So what will happen? Again permeability will go down. Right? Of course, if you are feeding, because if you remember the sintering process, we are keeping simply the fine particles together. Due to high temperature, they become a single piece of lump. If you charge fines, so they will become agglomerates inside the furnace itself. So where is permeability? Again, permeability is not there, right? So you don't want to do agglomeration or sintering inside the furnace itself by using fines, because it will reduce the permeability. Right? So these are the points. That is why we always need agglomerates rather than fines during iron making or in other some metal extraction. Okay, so we'll discuss about this one also. Binders. Binders nowadays we are using organic binders also, like some starch. Some people are trying to use organic binders. They're easily available, and yeah, they're easily available. Maybe they're cheaper. Organic binders. Starch, you understand starch. But technically in industry they are using a binder that is called bentonite. If you want, you can write bentonite. Bentonite is nothing but aluminosilicate. Your clay material, clay. You know clay is a binder. If you take the soil also and put some water and make a ball, it will make a ball. Ball can be easily formed. Because clay can easily form a ball because that is sticky material, right? The same clay, bentonite, you can use for binding purpose. You take iron ore, you put some, but the amount of binder used is very less, 1%, hardly, maybe. Only 1%. Rest will be your iron ore fines or whatever. See, binder is required to make green balls, but also you need water. If these are solids, you cannot make a ball out of it. So now the question is, what is critical amount of water? Critical amount of water means you cannot take excess water or you cannot take very less water to make balls. That is why it is called critical. Maybe around 10 to 15%. You need to add moisture, only 10 to 15%. If you increase the amount of moisture, the ball will be soft. It will be plastic. Right? It will be plastic. It can be deformed easily. It becomes plastic and it can flow. Right? But if you add very less amount of water, the binding will be not proper. Because binding is mostly done by binder as well as water also. Water will help you in binding. How? How water binds the particles? Because of surface tension. In the physics you have to remember there is a force called surface tension. You take two particles and put a little amount of water. So water will bring the particles together. So that is called surface tension. Right? So how binding is happening? Binding is happening due to binder also as well as due to water. If you put only binder and fine particles, you cannot make a ball. Never. You need water anyhow. Right? So water will provide surface tension. This surface tension will bind the particles together. That means water should lie in between the particles. Is it okay? There is surface tension, right? But if you put a lot of water, what will happen? It becomes slurry. Okay. Is it visible? Okay, fine. See, you people can see if you want. are iron ore pellets. These are not laddu actually. These are iron ore pellets. You can see. Nearly spherical. It depends upon industry. See, some industry don't care about their productivity, quality and all, so they don't make very spherical. But if you look into good industries like Tata Steel and all, they make completely spherical pellets. These are not completely spherical, but still it is spherical. Right? If you measure the dimension also, it will be around 16 mm. 15 to 16 mm. This will not break. If you want to break it, will not break.
So let's try.
So this is I told 10 to 15%. And this is basically 1%. Let me give a very natural example. Right? You go to a sea beach. So for example, you are going to a sea beach, and you will see first there will be dry sand will be there, right? The sand will be completely dry first. Then you just move beyond that. Then sand will be somewhat wet. But again you move towards sea further. It will be completely with water, right? You collect 3 sands, completely dry sand, and in between the sand, which is having dry and moist, and finally completely wet one. So the moment you pick up the dry sand, it will come to your hand. You try to make a ball out of it. You cannot make a ball out of it, dry sand, right? It is not possible, right? Similarly, you go to the deep and you try to pick up the sand, which is having lot of water. From your fingers it will flow away, right? The sand will come out. You cannot make a ball out of it. But in between the region where amount of water is critical or it is significant, if you want to take and make a ball, you can make a ball and you can throw it to your friend also. You can hit it. So the point was, the same thing is happening here also. In pelletization, you need critical amount of water. If it is high, it becomes plastic, it may flow. But if it is less, you cannot make it, because insufficient water means binding is not there. Surface tension will be less. Somewhere water is more, somewhere water will be less. So it cannot bind the particles. You understood? This is the real example. Okay, then, now this is, I think you understood, right? We need hard pellet, so we are actually what exactly we are doing? We are heating actually here. Induration. Induration means actually we are heating to make it hard. We are heating. So you can see this is one of the, limitation also. How this is limitation? In sintering, we are just charging fines and we are just hitting it. But here you are making ball first, then we are hitting the ball to make it hard. So additional process is there here, right? This is additional process. But this is one of the major advantages of pelletization is what? You can use very, very fine particles also. There is no issue. But in case of sintering, the particle size, initial particle size should be somewhat higher. Like for example, above 5 mm. Technically, if you go to any iron ore industries or steel making industry, you will ask what is the feed size for making sinter. They will say it is above 5 mm. Technically, initial particle size should be above 5 mm. But if the particle size will be very, very less also, in micron level also, you can make pellet out of it, no issue. You need only water and binder. So that is one of the advantages. So in other way I can say, even if you have a very low grade ore, so low grade ore means what you need? You need to do more crushing and more grinding. So anyhow at the end of the crushing and grinding, you will have very, very fine particles because you want more liberation and more release. So in that case also you can utilize those things. You can do pelletization to use that particular material. Right? So that means if you have a low grade ore, you cannot prefer sintering. Not possible. Because already particle size is so fine. You cannot make sinter out of it. Right? So you can also write what is the advantage of using agglomeration is you can utilize very fine particles, or you can say you can utilize very low grade ore also, technically. Because they need extensive liberation. So extensive grinding is required. So obviously particles become very fine. You can use pelletization process also in that. So that is one of the advantages. Okay, fine, this is clear. We'll move to steps. What are the steps? You can see the image. Yeah. Satyaj, you have shared the image. Huh? Yeah. Can you just look at the image Satyaj has shared for you? There is a pelletizer called disc pelletizer. Check the second image better. Second one. That is called disc pelletizer. I think that guy has worked on that. You did some research on that, right? So he did some internship there and he worked on that. It was disc or drum? Both. Okay, so to do pelletization you need a machine, a setup or whatever you can say. What is the machine you require? Either you need drum or you can need a disc. So I have sent you that one is a disc actually. Just see, that is a disc. It's like a flying saucer. Just imagine a flying saucer, right? It has a boundary and it is this inclined one. So you can basically mostly people use this one in industry. This one is better because of many reasons. One main reason is flow size. Flow size pellet. So this is one of the advantages. No screen sometimes required. Faster production. Or specific production rate is high or rate of production is good. So these are the more advantages of it. If you look into drum, so this is not there, this is not there. So these are the advantages of disc pelletizer over drum pelletizer. Basically use disc. See, which point do you think is the most important point? Just see, last one and the first one. The last one is fast production. Any industry want to do fast production so that they can sell it faster, then they can earn the profit, whatever. Right? Faster. If you go to any industry, 2 points are important. One is the quality and the rate of production, and the one is what? Energy consumption. Okay. Anyway. So quality is important and production is important. That means faster production and it should have good quality. Otherwise you cannot sell it in Europe or America, right? In India it is fine because India don't care about people life. Yeah, it is a serious matter. If you join some small industry, they do lot of corruption. You don't know seriously. They don't care about qualities. They will sell the metals without proper analysis. Yeah. They will bluff the customer. Yeah, it is this much of composition is there, but it is not true. Anyway, this is important. Why? Close size pellet means. Close size pellet means suppose you are making pellets, these balls. Close size means one will be 16 mm, one will be 18 mm. That is also fine. But if you use a drum, it may be 10 mm, it may be 15, it may be 20. So different size will form, right? So that is not good actually. If the size of the pellet will be very uniform, that is actually very good. You will get more uniform permeability inside the furnace. Right? You close size pellets, you understood? The pellet size will be nearly uniform. 16 mm, 18 mm, 17 mm like that, for example. But if you use a drum, size of the pellets will be very different. 10, 20, 15, 18, 17 like that. So that is not good actually. And faster production is fine. Screen, obviously you need screening. Suppose that means you understood where screening will be required. In case of drum, because different size of pellet is forming, so you need a screen so that you can get only 16 to 20. You can feed it to the furnace. But which are below 16, for example, or below, you have to recycle it again in the process. No, you cannot feed it. So that's why a screen is always required for drum. Okay, so this is fine. So in the steps, so first step is feed preparation. Feed preparation. Get ball in, ball formation. Sizing. Induration. So induration basically around 1250 to 1300. Sorry, now 1350 in this. Then next step is so it will give you hard pellets. So this is the sequence of making pellets. This is the sequence of making pellets. So first step is the feed preparation. So feed preparation, it is very simple. What you need? You need fine iron ore concentrate, right? You need binders. You need moisture. You prepare it. It is ready now. Fine. You collect all the materials and make it ready. Then next is ball formation. Ball formation means start making balls. You can make handmade balls also, but in industry they don't do. These are not these are handmade. These are not handmade. For research purpose they are doing handmade. I worked on that, how to make pellets, I know. So you can make pellets out of handmade also. Right. Ball formation means you are making balls, green balls. Fine. Sizing means you need required size. You cannot rotate the disc. You cannot rotate the drum for lot of time. Otherwise the size of the ball will be very big. Of course. So there is a particular time to rotate the drum or to rotate the disc, so that you will get a particular size of the balls, right? So ball formation, sizing, you understood? Making balls and proper size, whatever you need. Next is the induration. That means you will get what here? Green ball, right? Green ball. Induration, you can see induration is drying, preheating and firing. So can you tell me why we cannot go to directly firing rather than we are moving slowly? Drying first, then preheat, then why? Why it will break? Thermal shock will be there, no? If you take the pellet from room temperature directly 1200, so there will be a thermal shock, right? Sudden change in temperature due to thermal shock. The moisture present in it will be completely volatile, yeah? It will suddenly volatile, so it will break the green balls. So you cannot directly go to the fire. It will break. So you need to do drying. First you need to remove the moisture. Then once it dried, it become preheat, means somewhat high temperature like 500, 400 like that. Then slowly it will move to 1200 to 1350 or 1300. Then finally there will be a what? Very strong bond will form between them. So tell me now, if drying is done, water is get removed. Water will remove. Then who is binding the particles? Binders. Very good. So here, after removal of water, binder is there which will bind the particles. Okay. Very good. And there will be some mechanical interlocking will be there during ball formation. You have to remember. During ball formation, what happens? Mechanical interlocking is also there. Mechanical interlocking. And so these are the 2 points you have to remember. How green balls are forming. Green balls are forming because due to surface tension of the water, which is holding the particles, and one is mechanical interlocking. Mechanical interlocking means what? For example, just imagine a surface is like this, and another surface is, for example, like this. You mix them, so they will get interlocked, right? During balling action, they will get interlocked. So that is called mechanical interlocking. Right? Then firing. So firing, what exactly happens? You are taking it to a very high temperature, right? So they will become softened. Somewhat melting will be there. Some melting may be there. Some softening will be there. And two kind of bonds will form. One is called slag or glass bond, and is one bond solid state bond. See, two types of bonds basically forms during your firing. Solid state bond means this is very okay fine. You will study a subject called powder metallurgy in your coming semesters, maybe in 6th or 7th, whatever. Suppose you take one solid particle, you take another solid particles, you put it together, just close to one another, you heat it. After some time you will see that they got bonded between them. The bond will form automatically. In the solid state, you are not taking it to liquid, but still the bond will form. Why? Because some atoms will migrate from here, some atoms will migrate from here, they will form a neck like this way. I am not going into details. For example, this is particle, this is another particle. They are together. This is so after this, how this will be? This kind of thing will happen automatically. See, these two particles got bonded in solid state. This solid state bond basically forms due to diffusion of atoms, migration of atoms from one location to another location. Basically, there are a lot of things. I am not going into details. It is a very big subject actually. If I go and it will not get complete, not required. Diffusion will happen basically this thing. And this one is mechanical interlocking, I told you. This is mechanical interlocking. And surface tension means this is the particle and this is your water. This is your water. So this is because of surface tension. Okay, anyways. And slag and glass bond are nothing but what exactly happened. If you remember, this is a very important point. Just remember this. Whatever you are, this suppose for example iron ore. So iron ore has silica as a gang, alumina as a gang, right? So these are the gangs. So the moment you take it to high temperature, what happens? This silica sometimes becomes fused automatically. It will react with FeO and Al2O3, and it will form a ternary compound that is called phyllite. Basically, phyllite. You have to remember Al2O3 dot SiO2 dot ACO. This is a compound automatically forms at high temperature. If this compound will form, this is a ternary compound. 3 different components are there. This is called ternary. You know the binary compounds, ternary, quaternary, right? So this is a ternary compound. That is what phyllite. So if this compound will form, the melting point will go down automatically. So it becomes liquid. So you have solid particles, and this compound is forming, which is a liquid. So that lies between the solid particles, and when upon cooling, a bond will form between them. That is called slag bond or glass bond. Glass bond means it is a glassy in nature. It is amorphous, not crystalline. This solid state bond is a crystalline bond basically, but this one is a glass bond or slag bond due to presence of slag. You can add some flux also, like in certain cases they are adding some flux nowadays. You want flux, flux pellets, but this is advancement actually. It is an advancement in pelletization. Earlier they don't use any kind of flux. Because why? If you add flux and you make pellets, So they will stick with one another. So you have a group of individual pellets. There will be no individual pellets, it will be a group of pellets. So you cannot feed it into the furnace, a group of pellets. If you add flux during the making of ball, right? But nowadays there is some advancement, they are doing something. I don't know exactly. He worked on that, I remember. Okay, fine. So this is clear, I guess. Up to this, what are the steps? So just imagine this is a disc. So this is a disc. Okay, fine. Left. Okay, anyway. And you feed. So there will be a disc, you have seen the image of the disc, right? So there will be a disc inclined at 45 degree and it is rotating. From the top you are feeding your fine iron ore and binders and moisture is coming also, right? So they will mix and disc is rotating. So automatically in the disc you are feeding the materials and it is rotating. So what will happen? It will start forming balls. First small ball will form, then it will become bigger, it will grow, and finally when the acceptable size will be there, it will automatically come out. The small balls will grow and it will automatically come out. Fine. And there is a scraper. Why scraper is required? Otherwise it will stick. The fine, because of moisture and binder, it will stick to the disc. So there is a scraper which will remove the sticky material. So it will go on. Fine. Okay, we'll discuss in the coming lecture about this one on in more detail.